Connor, can you confirm that we are live on Twitch? I guess I can confirm it, but then my computer will die. All right. Welcome to pwn.college. I really hope that wasn't the my headphones disconnecting. That would be unfortunate. Nope, seems like they're live. We are doing. Oh no, sorry, I forgot. Let me stream my video. I am running into exotic problems. Okay, we're good. All right, this first time is going to be quite a clusterfuck. So don't panic. All right. Here we go. You guys should all see my video. Perfect. And OBS says we are streaming. Man, influencer life is so close. Okay. So we're live. Welcome to Pwn College. Welcome to CSE 466, those of you at ASU. This is going to be an interesting experiment. So when ASU moved all large classes, such as this one, to ASU Sync / Zoom, I figured since we're going to be broadcasting this from my office anyways, why not just try to broadcast it to the world? So we've made this decision, I don't know, 2 weeks ago, and it has been 2 weeks of absolute insanity for me and Connor, and you know, just kind of crazy. So to introduce myself, I am Jan Shortashvili. My handle that I go by in certain places is Zardis. I am a cybersecurity professor here at Arizona State University. And Connor, who is the TA of this course and the co-creator of this, the framework and everything that you'll be using throughout this course, is one of my awesome graduate students who does cutting-edge research in cybersecurity and also participates in competitive hacking competitions. I guess that's obviously the hacking competitions are going to be competitive. I spent quite a long time participating in cybersecurity competitions. Still do. Sometimes I also now run the kind of world championship of CTF, which is called DEF CON CTF. CTF is cybersecurity competitions. Anyways, we're getting a little ahead of ourselves. Let's start with an intro video to the course. You might have noticed if you looked on pwn.college and then followed the YouTube link that this video is already on YouTube. This will be the only time in the course where we replay a YouTube video. It's just I didn't know a good way to make sure everyone watched this before we dove in. So we're going to watch it now. Connor, can you check real quick how we're doing on Twitch? Are we famous? Oh, hell yeah. All right. Let me bring up the chat in case, excuse me. Twitch quality is better than Zoom. Okay, that's not what we wanted to hear. Damn. Is it soup? Okay, no lag on Zoom. Good. This is going to be, hopefully this works. Otherwise, we'll have to be very exotic. At one point when we were setting this up, I had 2 cameras. One for a machine connected to Zoom, one for a machine connected to Twitch, but it was a nightmare. All right, we got some people trolling on the Zoom. Let's all be good. Okay, should I bring up the? Okay, Connor, you're monitoring the Twitch chat for any questions there. Perfect. Let's roll. All right, so I'm going to switch over and play you that first lecture, What is Computer System Security? There's also a series already online of fundamental knowledge that you should already possess entering this course right now. I'm going to stress that over and over and over in this introductory segment. but this is going to be a very difficult course if you don't already have that knowledge. Anyways, we'll get to that in a second. Those lectures are already up along with this one. I'm going to pause this for some discussion since we can do it live. On the video, I say, unfortunately, we can't do the discussion, but I forgot about the pause button. All right, let's jump in and roll. By the way, tell me ASAP if you don't hear audio coming from this video. Also, it's super weird to see my office and then my office in the corner, but that's fine. All right, here we go. What the fuck? Okay, all right. Well, we knew this was going to be chaos. Can someone turn off the Zoom overlay, Connor? Yeah. Someone's drawing on my screen. I'll go figure out how to do it. Where's the freaking setting for this meeting? Amazing. There are no... Okay, I have an idea. One sec. I'm going to join from my iPad, and I know where the fucking settings are from there. Hold your horses. Where the hell is it? I'll do that. All right. First things first. Let's turn off these annotations. All right. People asking about my games. I'll get to that in a second. All right. Play, join, and leave sound is now off. Perfect. Allow participants to share screen. No, but how do we turn off these fucking annotations? Students. Zoom disable annotations. That should be right there. Disable participant annotations. Amazing, it didn't work. All right, well, we will simply persevere with some wonderful student having drawn on my screen. All right, but at least it's not showing up to everybody. Okay. Oh, it is showing up. God damn it. We can just stop share and restart share. All right, there we go. Let's roll. Hopefully annotations are truly disabled now. We can't roll because the audio capture doesn't work. I tested this. That's annoying. All right, let's try this. One sec. Oh, hello there. Can you hear that?
No.
Great.
I think we could hear it on Twitch, but not on Zoom.
Of course. All right, everyone. We can't just switch between Twitch and Zoom. What is a good way to go? Can Zoom share? Okay. Good idea. If you'll do the camera route on OBS. Thank you for bearing with us with this insanity. We'll get better. All right, this is gonna work. I'm gonna stop share. I'm gonna start video here. Okay. Now, if you pin my video, can you hear that? Oh, hello there.
No.
No, great. All right, hold on. One more try. Yeah, I can't set the microphone to the fucking webcam. Okay. All right. We're fucked. I mean, we're in trouble. We have no way to share. Oh, hold on. I think I just got it. Okay, one second. I think Zoom is dead, or Gnome, one of those.
Us, but you are frozen.
This meeting is being recorded.
Hey.
Twitch seems to be working just fine, but Zoom is frozen. I have both videos up right now.
I'm back. Don't panic. We're good.
Hey.
All right. Now I'm gonna share screen. Yes. All right. I know how to do this. There's a Zoom in its infinite wisdom has a audio button. All right. Here we go. 3, 2. Let me change this back to the default. Computing, man. Okay. Oh, hello there. Did everyone hear that?
Nope.
Not in Zoom.
Are you shitting me?
Yes. No, we did.
Oh, you did?
It was just delayed.
Delayed in Zoom or delayed in
And I will be.
It's coming
Zoom,
through
I
Twitch.
No, we didn't.
Zoom.
I have
Okay.
Twitch closed.
Still only on Twitch.
You know, alternatively, we probably could just use Twitch for the video part.
Yeah. All right. Here's what we're gonna do. Let's we're gonna run the video. You can view it in Zoom, but you'll have to listen to it on Twitch, and then we will. I'll pause for discussions, and of course, those of you on Twitch, you can't speak to me, but you can type. Connor will relay your messages, and we'll have a live discussion that way. Those of you on Zoom, we can talk directly with the ASU students. All right, let's roll. Otherwise, we'll run out of time debugging this stuff. We already stayed up to like 5 a.m. yesterday doing it anyways. Anything I forgot to do? Oh, bring up the chat. Yes. I knew I was forgetting something. All right, awesome. Let's roll. Oh, hello there. My name is Jan, and I will be talking to you today about computer system security. This course will cover a wide range of concepts within computer system security from a couple of different vantage points. But first, I wanted to have this sort of introductory video to get at the meaning of the term and the conceptual, philosophical meaning in which we'll be operating, right? So what is computer system security? Let's deconstruct this into its constituent parts and then talk about it as a whole later in sort of interesting example that we'll look at. Let's start with the term security. Right? Security is a term with many meanings. It can mean different things to different people. Emotional security, financial security, physical security, etc. Right? To us, we're talking about it from the perspective of systems security. And what does system security mean? System security means the security of a system with respect to a specified property, right? So let's take an example. Let's say we have a system that is a vending machine. This isn't necessarily a computer system. We'll get to that later. This is a system, a complex system that has a certain goals, certain properties that should be maintained. One of these is that you should not be able to receive snacks or drinks or whatnot without putting in some money into the machine, without payment, right? So let's look at examples of how the security of such machines, of such systems, can be compromised. Usually when I teach this course in person, this is a discussion, a back and forth Q&A where we kind of come up with attacks, come up with defenses. Unfortunately, right now there's a one-way transmission. Psych, it's not. All right, that Jan is paused. This Jan is going to lead this live discussion. Let's talk about vending machines, right? So we're talking about system security. A vending machine is a system that is designed to take your money in exchange for delicious snacks and beverages. Let's come up with a couple of potential attacks against this system to violate its security. So you walk up to a vending machine. Let's say it is a very insecure vending machine. What is the simplest attack against a vending machine that you can think of?
Put in Monopoly money.
Put in Monopoly money. All right, so we have a very simple, that's an awesome answer, by the way, that I have not heard before. We have a very simple machine. All it does is just make sure that there's like a, number one on the paper you put in, and then it's like, all right, that's $1, right? So that's obviously a machine with a bug that is a really, flaw in its design, let's say, but in the implementation of the money input, and it leads to a violation of the security of this machine in that it's going to vend you snacks, but you have to put in Monopoly money. All right, so the system of the security of my system was violated. Someone was able to get all my snacks. As the vendor of the machine, or as the operator of the machine, I am upset. I go and I fix up the security of the system. So I say, okay, no more Monopoly money. I'm going to install a money reader that is, the cutting edge. Just make sure that is real money, right? Does all of the IR, whatever crazy spectrum analysis, make sure it's real money you're putting in. What now? Is the system secure?
No way. I can use a sledgehammer.
All right, sledgehammer solution. And then we have another solution on Zoom in the chat where it's the bend the arm through the entrance, right? So two attacks. Let's talk one by one. Sledgehammer through the glass. All right. That's quite a valid attack. That is, brute force attack against the vending machine, and suddenly you get all of the goodies, and the operator again gets no money, and also has to fix a window. That's a problem with the design of the machine, and you'll notice that there are vending machines that have reinforced glass, right? Glass with steel reinforced in it, and to fix this exact security hole, right? So again, there was the money problem, then that got fixed. Then there was another attack violated the security system again. That got fixed. Now there's another attack, the bendy arm through the output, right? Someone gets their hands into the output, goes up, grabs their sodas or whatever. Yet another security attack. The security of that machine was violated again. Well, now we need to add more patches, fix the machine again, where we have kind of some sort of a door that is closed until the candy or whatever vents, and then the door opens. And when it opens, it of course has to block off the entrance to the machine. You kind of see it, kind of like what this thing is probably that. All right. Now the Zoom is going crazy with all sorts of suggestions. Do we have anything from Twitch, Connor, for a follow-up attack? Connor might be dead.
1 second, sorry. There's tons of stuff in Twitch. So someone says, force the owner of the machine to open it for you.
Okay. So you kidnap the owner of the machine. This is a serious security one. There's an XKCD about this, where you have all of these, security measures, and then someone just beats you with a wrench until you tell them your password. This is the equivalent, right? You kidnap the owner of the machine and just beat them with a wrench until they open the machine for you. So now, this is a serious security flaw. Despite our awesome machine, we had to still give up all of our candy. So now, of course, some sort of fix for this would be, let's say, an anonymization of vending machine ownership records. Vending machine operators are protected like, CIA operatives or something, right? Where it's a secret and everything. All right.
The vending machine refillers.
Okay, you you do a supply chain attack. There was a suggestion on Zoom just now. You go and you attack, instead of the vending machine, the people that refilled the vending machine. That is yet another shockingly effective attack. So we have, this whole system is actually more than meets the eye. It's not just the vending machine. It is also everything in the people that make the snacks, the people that load the snacks, all of this crazy stuff, right? And it's getting more and more complex. And then you have, attacks. You have to protect against the kidnapping of these people, the bribing of these, and so forth, right? So the point is here, and we're gonna move on now because we can be at this all day. There's no such thing as an impenetrable vending machine. Although the supply chain attack one is great. I also haven't heard that one before in this exercise. The point is that this can all be broken quite easily. And actually, rather than lecturing myself, I'm going to let recorded me lecture. So we're going to fast forward a little bit. So we'll have maybe some of us drink or whatever. It's designed in
I babbled for a while.
naive way. Means takes several different approaches. You could just have some sort of little, capsule ways to a fix, a patch, let's say, right? And with a hammer, was able to retrieve the glass so that bypasses
cool.
our first defense attacks, like bringing in counterfeit currency. And now, this machine has to have a way to detect counterfeit currency. Trying to pay with something that is the shape of a quarter and the weight of a quarter, or tying a string to your quarter and pulling it back. These are all attacks that have been performed on real vending machines that real vending machines now have to defend against in order to be secure. Right, and vending machines nowadays, of course, are more and more complex systems. There are vending machines that take credit cards. This opens them up to a whole other range of attacks. There are vending machines with which you can talk with your phone and so forth, right? So the complexity of these systems is rising, and the security of these systems is more and more complicated, right? And this discussion is really meant to highlight one thing, and that is that a chain is only as strong as its weakest link, right? The story of the vending machine compromise has repeatedly been, here's a big complex system, let's try to find one clever thing we can do, whether it's putting our arms up through the outlet of the merchandise, or figuring out that we can break it with a hammer, or tying a string to a quarter and so forth. One little thing we can do that takes advantage of one part of the system, one small weakness, to fully break the security, to get snacks or drinks or whatnot when we haven't paid, right? So with that in mind, let's move on and talk about computer systems, right? Computer systems are, as we know, not secure. Otherwise, we wouldn't be seeing the huge amount of data breaches and chaos that we see in the context of computer system security, and they're very complicated and not super approachable. They're also growing rapidly in complexity. So this graph here is a graph of the amount of code, just amount of code in the Linux kernel over the years. And we see over the years just this monotonic almost growth continuously. And an interesting thing that we see is every year a bunch of code is added, and then that code is rewritten, refactored, removed over time, but a lot of it stays around. So in the Linux kernel, even today, there's a ton of code that was added in 2006. It looks, just based on a rough look, maybe a tenth of the code in the Linux kernel is 14 years old. 14 years ago, cybersecurity was a completely different world. And cybersecurity practices, safe program practices were very different. So this is a interesting influence on the security of these code bases, and that there's a lot of old code, there's a lot of code that people might not understand, and vulnerabilities get introduced. So let's look, once we get through these takeaways, that computer systems are complex, and with these complexities you can get vulnerabilities. And as we saw from the vending machine example, a single vulnerability can break the security of the whole system. The chain, again, is only as weak as strong as its weakest link, and if you figure out one place to jam your violation of security, you can leverage open the whole system very frequently. So let's look at this as a whole. What is computer system security? From the view of an example. And the example focuses on this character. This is not a Muppet. I mean, the picture is technically of a Muppet. But the character behind the Muppet, the individual behind the Muppet, is responsible for a very high profile hack that is really a perfect example of a single flaw or a small collection of flaws leveraging open the security of an entire company and leading to extreme real-world effects. A lot of this is gleaned from an interview that this individual gave to a reporter for a famous online magazine. I always slips my mind exactly which one. I think it might have been Wired. And for real, there was, you can find this online, this interview of an actual human reporter right there, talking to, right there, a puppet. And the human reporter is asking questions, and the puppet is responding using, voice anonymization and so forth. It's super interesting to watch. Along with this hacker also wrote a write-up. There'll be links to it in my slides, and I highly recommend you read this for a example of real-world, actual systems compromise that is kind of not sanitized, it's just raw and described as is, which is super interesting to read. So this hack was pulled off. The individual's handle is Phineas Fisher. It's unclear who exactly they are. They might be, multiple people. It might be an entire group. They might be one person. But sometime in 2016, Phineas Fisher took issue with the actions of a company called Hacking Team. Hacking Team was an Italian company that created a number of hacking tools, and Phineas Fisher was unhappy about the clientele of Hacking Team, which allegedly, initially allegedly, and then eventually, after this hack took place, very publicly included oppressive regimes and so on. So in 2016, on one sunny day in July, 2015 now I see from the tweet, I always mix up these dates. July 6th, 2015, Hacking Team changed their Twitter handle to Hacked Team and tweeted, since we have nothing to hide, we're publishing all of our emails, files, and source code. And these files included audio recordings of phone calls, just an enormous amount of information. It was a brutal disclosure. And of course, they didn't do this willingly. Phineas Fisher compromised Hacking Team's entire cyber infrastructure and disclosed all of this on the internet. So how did this happen? How was the security of this computer system so thoroughly violated as to essentially destroy this company? Hacking Team can cease to exist in any large, high-profile capacity as a result of this. They were hit with a lot of scrutiny, a lot of criticism, controversy, and so forth because of the disclosed information, and their business suffered very heavily. So let's walk through the steps that Phineas Fisher took to hack Hacking Team. I mentioned there'll be a link to a write-up. That's the link down at the bottom of the slides. These write-ups keep getting taken down for whatever reason, so that's just kind of the latest version that exists out there. The write-up is interesting in that Phineas Fisher lays out exactly the steps that they took to carry out this attack. It's super interesting, and we'll follow it step by step. Step one of this compromise was reconnaissance, right? So Phineas Fisher decided to attack Hacking Team, and they looked into what attack vectors are possible. In the write-up, they talk about the different ways that you can get information on a company by looking through press releases, by downloading PDFs released by that company and looking at metadata embedded in the PDFs, by looking on LinkedIn and all sorts of other routes, right? But in the end, using mostly kind of internet reconnaissance, Phineas Fisher concluded that Hacking Team was actually pretty good in terms of their external internet-facing security. They had very little network-facing infrastructure, mostly a web server, a mail server, a VPN endpoint, and some routers, right? That's a very small digital presence. They had a pretty low public profile and professional external security practices. I mean, these were professional security engineers, right? It's a daunting target. So with this information in mind, Phineas Fisher proceeded to gain a foothold in their network. That was the next step, right? So how did they do it? They looked in one of the embedded devices, routers or appliances or something. Phineas Fisher doesn't specify in their write-up which exactly device, but they took this device, metaphorically speaking, downloaded the software that runs on this device, and you can do this in a number of ways from, let's say if you have a Linksys router, You can go to Linksys's website and download a firmware update, unpack it, and there's the software. So Phineas Fisher downloaded the software, spent a couple weeks analyzing that software, and found a 0-day vulnerability previously unknown to anyone, and now unknown to anyone but Phineas Fisher. So Phineas Fisher had a, get into the system free card, so to say, and they used it to gain a foothold in Hacking Team's network. After that, having gotten on the network, they performed internal reconnaissance, right? And they had the luxury of taking it slow and steady because, again, the vulnerability that Phineas Fisher used to get into the network was unknown to anyone but them. It is as if you wanted some snacks and you figured out a new way to contort your arm so that you could get past the vending machine's output blocker and get some snacks, right? So until other people catch on, if no one sees you use this trick to steal snacks, you're kind of sitting pretty on quite a lot of stolen food for whatever reason. But anyways, maybe a bad analogy, but that was the situation with Phineas Fisher sitting on Hacking Team's network. So they had the luxury of taking it slow and steady. They did initially passive network listening and then careful, slow, active network scanning to identify several other pieces of infrastructure on Hacking Team's network internally that were now fairly accessible, right, and that weren't properly secured. So again, this is where things start getting really bad, but keep in mind that this is inside their network, right? Inside their network, things weren't secured from people that were already inside their network, but that's, from my experience, not a very uncommon thing. So anyways, they found an unsecured server that had audio recordings of the physical security system. So that's already pretty bad, right? That was a lot of audio that ended up in that final disclosure, and that's not something that you want around. Aside from a lot of confidential information getting set over the phone or whatever within earshot of your cameras, there's a lot of interesting techniques where by using the sound of your keyboard typing, you can recreate, the keys that you press. For example, recent research has indicated that you can use the sound of your key going to a lock to actually synthesize a copy of the key itself. Right? So this is maybe theoretical sci-fi-ish attack still, but leaking all of your audio recordings is already bad, but it gets worse, right? Phineas Fisher kept looking, and one thing that they found was a badly secured backup server, which is very bad because on this backup server was a backup of the mail server. And by analyzing the backup of the mail server, they were able to extract the credentials of the administrator of the mail server, and these credentials were still valid on the running mail server. So this is kind of flaw 2 and 3 here, where there was an unsecured backup server, and on that unsecured backup server was a backup that had a password in it that was still active, right? But when you take backups, do you remember to change all your passwords after every backup? I mean, I've never heard a policy like that, but from this perspective, that would have been a good policy. So it turns out that having full control of the mail server, it'll come in useful later for Phineas Fisher, but it also helped them spread out over the network because they were able to use that mail server to gain administrative privileges over the entire Windows domain that Hacking Team had. Using that, they installed a key sniffer in the on the on the machine of one of the engineers, one of the administrators, and was able to catch a password being entered by that administrator to unlock an encrypted volume containing even more passwords. And then they had basically free reign inside the hacking team administrative network, right? Or the production network. The problem is that Phineas needed access to the development network as well. Hacking team carefully segregated their networks to maintain some best practice separation between the network that they did their development of their hacking tools with, that had the source code of their hacking tools, etc., and the network that they did for everyday business. Whoops. And using the passwords that they recovered from the encrypted volume, they were able to log into a monitoring server that had access to both networks. And using an end day previously known but unpatched vulnerability in that monitoring server, they were able to gain complete access to the development network, because there were reused passwords between the development and the production network.
Just a quick interjection here. I think I mixed something up when doing the lecture. The reused password was just between the networks. Phineas used an end day to get onto that monitoring server, and then I don't think that there was a password involved in that. Anyways, the full write-up is linked there. It's a pretty interesting story.
Right. This is more minor things that hacking team did wrong from a security perspective. Password reuse and allowing an unpatched vulnerability to be present on their network. But again, this was inside their network, right? And many companies often ignore or deprioritize the security posture inside the network. All right, step 6, of course, having compromised the development environment and gotten all the source code and so forth and so on, Phineas bundled it all up, uploaded it to the cloud, and used their mail server, their control over the hacking team mail server, to request a password reset from Twitter. Of course, they emailed that to hacking team, to that mail server. Phineas grabbed the link, changed the Twitter details, tweeted out this gloating blurb, and released this data to the world. Right? And again, the security of hacking team from the outside, before Phineas Fisher started, looked pretty good. Right? This was a careful company of cybersecurity professionals. And this whole security chain unraveled when Phineas Fisher found a 0-day vulnerability in a device that hacking team were using. In some sense, that's not even hacking team's fault from a security perspective, right? That is kind of the takeaway of this story, that computer system security is so difficult to get right that, as we can see through this and tons of other disclosures, even professionals get it wrong all the time. So what went wrong as a summary? There's a bunch of things, a couple of different weak links, but for the most part, they were all minor, right? The lack of two-factor authentication for their internal accounts. But let me ask you, do you use two-factor authentication to log into your laptop? Password reuse. Everyone I know reuses passwords to some extent. Even if not on the internet, then oftentimes on their local computer accounts. I'm going from the bottom up here, but it's a bunch of different stuff, right? They didn't isolate their backup system because possibly because they didn't expect passwords to get backed up, but the passwords did get backed up.
and it goes all the way up to this 0 day in the physical infrastructure, or in the public facing network infrastructure that we discussed. That's a very, very hard thing to avoid. I can guarantee you that most likely whatever public facing network infrastructure you're running has 0 days that you're not aware of in it, just because this stuff on average is very, very insecure, right? In some sense, all of this security infrastructure that we have built up is just waiting for one vulnerability to crack it all open. So the takeaway that I'm trying to convey is that it's easy to think, oh, okay, well, hacking team screwed up and they got hacked. But the story of computer system security is really that the likely scenario, if that had been your company, things would not have gone very differently. All right, now we're gonna dive into a discussion of ethics in computer hacking, because this is a course that's going to approach this problem of computer system security from an offensive perspective. I want you to understand the types, at least on several very concrete approaches to the problem, the types of vulnerabilities that arise that compromise these entire systems, right? For that, you need to be very careful about ethics. We need to make sure that the knowledge we learn in this course and our general interaction with cybersecurity is ethical and correct, right? So what are the ethics of the hacking team hack, right? Obviously, Phineas Fisher broke into a system that they were not authorized to access. That is essentially the digital equivalent, of course, of breaking into someone's home or business. Phineas Fisher, in their write-up, discussed that they are doing this, that they pulled off that hack because hacking team was unethically selling software to oppressive regimes, and that's complicates this discussion in an interesting way. But in general, as ethical computer hackers, I have to stress very thoroughly that you should not practice cybersecurity against any targets that you are not authorized to practice cybersecurity against, right? So let's get into some hacking ground rules. Rule number one is please do not do anything illegal. I mean, that should just be obvious, but it needs to be stated and it needs to be stressed, right? Approach cybersecurity in an ethical, careful way. What does this mean specifically? It means if you don't have explicit permission to hack a system, do not hack it. It's not hard. That's a pretty simple thing. Don't hack systems you don't have access to. In the same vein, don't attempt to find vulnerabilities in systems that you don't own or have permission to audit, right? So what does that mean in practice? I mean, how do you even become a hacker, get good, and so forth? Well, you can run a server for yourself to hack, right? If you're interested in finding vulnerabilities in devices, you use your own devices. You can stick to software and services that have bug bounties. Believe it or not, the current state of cybersecurity is that most companies, many companies, will actually permit you to try to hack them as long as you promise that they'll be the first to know. A lot of companies will actually give you money for that. I'll discuss some of these monetization opportunities in a different video, most likely. You can, of course, become an academic like me, my colleagues, researchers working, doing awesome work in my lab and other labs around the world. And academics get some leeway. We can do research that is very tricky to do as a non-academic. Research into, for as an example, the security of digital rights management. Laws such as the Digital Millennium Copyright Act have exceptions for research. Or if you really want to get a lot of awesome practice, you can become part of the competitive hacking community. Believe it or not, there are active competitions of computer hacking out there. I run one of the big ones, and I'll also discuss that in a different video to try to get you all moving into the competitive cybersecurity world if you're interested. All right, so what are the takeaways, right? Again, very important to stress, a chain is only as strong as its weakest link. This is the attack-defense asymmetry, right? In order to protect themselves, hacking team or any other group that has been recently compromised or hasn't yet been compromised has to block every attack. That's very hard because the attacker just has to land one, right? This is the typical attack-defense asymmetry. Good defenses fail. Hacking teams' external network-facing infrastructure was good. It seemed secure, but it didn't save them, right? And very, very, very importantly, hackers have to be careful around ethics, right? Our field is a very cutting-edge development field with high impact in the modern world. We need to take that very seriously, and as you learn various ways to identify and attack security in computer systems, I would encourage you to always keep this in mind and always stay ethical. That's all for this video.
All right. Sorry, I muted the wrong thing. Okay, perfect. That is all for that video, as that video said. So the takeaways, of course, is this attack defense asymmetry, that security breaks down very, very fast in exotic ways when some single failure occurs along the chain. Can we do a quick test to make sure we are live on Zoom still? Connor, can you say something? But can I hear you on Zoom is the question. Okay, perfect. Awesome. All right. Awesome stuff. So that pre-recorded video, I apologize. It's probably not so exciting to watch something live that's available on YouTube. How will this class work going forward? Let me discuss this with you right now. I'm going to pull up some slides. First of all, any questions from that video on Twitch or Zoom? I now have Twitch open on my other device. All right, someone said that it was a very entertaining thing. That's great. Anyone on dang, black shirt Jan is not nearly as cool as blue shirt Jan. I like it. That's good. Good. Okay. So it sounds like everyone is pretty amped on that video. Let's move on to this course. Let me pull the right slides up. Oh, they're already there. All right. Here we go. Let's talk about what to expect in this course and how it's going, or it will go. All right. I mentioned earlier that you'll need some prerequisite knowledge to succeed in this course. I'm not joking. This course expects that you know on a relatively deep level Linux, ideally Python, C, and x86 assembly. So there are videos
for this module where I go through a lot of these. If you already know it, I still encourage you to watch these videos just to fill in any gaps that might be in your understanding and so forth. I go fairly in depth about, for example, the life cycle of a Linux program and so forth, and it'll set you up better for the rest of the course. Regardless of what knowledge you come in with, this is a course about learning fast, right? This course will explore an enormous amount of topics for one semester class. We're going to start with on this introduction and fundamentals and Linux. An assignment will split into groups to start shortly here. Then that will last 1 week. So assignment will be assigned during this class. It is due at 4 p.m. next Wednesday. Then we go with shell coding. That's live for 1 week. Then sandboxing, binary reverse engineering, simple memory corruption, return-oriented programming, dynamic allocator misuse or heap flaws, format strings, race conditions. Then we'll have a guest lecture on the week before America has its voting day. So I don't want to have an assignment that overlaps and especially is almost due on voting day, which is November 3rd. So if you can vote, go vote. Obviously, that's not like a homework assignment or something, but don't worry about this class for that week. We'll have a guest lecture instead to kick off that week, and then you can use the week to catch up on previously missed homeworks and so forth. I'll talk about that in a sec. Then we'll go into kernel exploitation. That is a big reach. Last year we almost got there, but this year we will get there, and we'll blow all the way through to automatic vulnerability discovery. Those are the that's the game plan. Those are the planned modules. We have 2 wildcard slots that we can use either for a delay if shit really hits the fan and everyone is failing. Don't count on that. Or additional topics, potential additional topics, web security, cryptography, maybe security and machine learning. Who knows? We'll have something for you there. And then on the last week, there's no final to this class. Actually, there are no exams. It's all these cybersecurity challenges. On the last day, we'll have a guest lecture and then closing remarks. Any questions about the course? All right. Let's see. Someone sent out a .ru link where you can vote early online. That's probably not. All right. Someone asked, will there be any mercy? I will get to that in a second. So let's first get to what every topic will look like. Every topic will have a lecture introducing the topic and additional lectures going in depth into aspects of the topic. I'll try to work in real world examples or historical context or something along these lines into, of course, every topic. That's always interesting. And then practice challenges. There are going to be tons and tons and tons and tons and tons of practice challenges. To drive the point home, the homework that we will assign tonight is going to have 100 practice challenges. Okay, that's to get across. It's a representative example of the types of challenges and the types of assignments that you will see. These lectures, with the exception of that lecture that I just played, will not be played in class. They will be available before class, and we'll use class itself for an extended Q&A about the concepts themselves and for collaboration. I'll get to that in a second. Grades. Someone asked on Zoom if there will be any mercy. The grades are very simple. There's going to be between 7 and 14, however many topics, there'll be that many assignments. Each assignment will be scaled to 100 points. So this first assignment, it's very easy. A challenge, 1 point. Every other assignment, it's gonna be I don't know, if there's 30 challenge problems, then you solve 30, you get 100%. It's not hard, right? Your grade in the course is the average of all your grades on all assignments, period. Right? There are no quizzes, no exams, nothing. You're not gonna take an exam. Well, I mean, you will, but in the real world. But realistically, I want you to learn how cybersecurity works, how all of this. Oops, let me move myself. Flow to the top there. How cybersecurity works, and et cetera, so that you have a good base for your future career or your future research or whatever it is in cybersecurity, or your future nightmares, whichever. Extra credit opportunities. There are several. The first one is super doable, right? So if we have 10 topics, let's jump back and look at the planned topics here, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 for sure, and then 2 more wildcards, right? So every homework is going to be worth between 10 and 8% of your grade, roughly, right? In the end. However, there was some weird thing on Zoom for a second. There's a question on Zoom. Is this course harder than CSE 340? Connor, what is CSE 340? Is it a very hard class? I have no idea. Okay, the answer is this one is harder. Okay. There's another one. Jan, would you like the Discord link? Which Discord? Anyways, it's not. We'll deal with it later. Will 365 be enough of an intro for this course? Yes, I think so. This course will be hard regardless, but I think 365, depending on the flavor of 365, it changes slightly, should be enough of an intro. If you have questions specifically, ask me. Connor, if you could respond on these, is it harder than X? We have now 355. You can. There's a Discord for my course, and I didn't create it. Fascinating. Okay, Connor says it's harder than any undergrad class, so I would trust him. All right. Anyways, extra credit opportunity. Like I said, every homework is going to be from 8 to 10% of your grade. The extra credit opportunity is huge. Every weekend, I mentioned competitive cybersecurity. I'm going to show you what. No, hold on. That's going to look like shit. I'm going to show you real quick this. This is ctftime.org. It is a tracker of capture the flag competitions, cybersecurity competitions, where anyone can join and do their best, right? There are tons of them. There's one every weekend. This weekend, there are 2, 3. Next weekend, already there are 2 scheduled, and then more coming up. That will likely be scheduled. They are open for everybody, open only for academics. There are ones that you have to pre-qualify. It's not important. The point is, look at these ones that are open to everyone, and you can find a whole set of competitions every weekend. Why am I telling you this? Because every weekend you have the opportunity to increase your final grade by 1 percentage point, right? So you find between 4 and 8 students to participate in CTF, a minimum amount of 4, maximum of 8, and you dive in to a CTF listed on CTF time for that weekend. Do your best. You don't actually have to solve anything, but I highly recommend it. Write a write-up about what you worked on, what you solved, what you failed at, what you learned, and so on. I think someone asked on Zoom how many weekends in a semester. I think it should be 14. Or let's say it will be 14 starting from this weekend onwards. I think if we look at, we extend the, shit, hold on. God damn it, okay. Sorry, I was failing at computing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So every Wednesday, there are 15 Wednesdays, and Connor, how can there be 15 Wednesdays? All right, I guess there are 15 Wednesdays. Well, that's interesting. So, yeah, there are 15 Wednesdays. That implies that it's very likely there are 15 Saturdays and Sundays. So I am actually wrong on the slides here. I say 15%, 14% extra credit. It's actually 15. So 1 per weekend. There's a question. Last weekend is outside course time. Well, damn. 14 weekends then. Sorry. Questions from here. Do participating CTFs with the Pwn Devils count? Yes, I will give you an exception to this 8-person maximum as long as your write-up, if you're playing with the Pwn Devils or when they play together with Shellfish, that's also fine. But your write-up needs to very clearly convey that you as an individual participated and were an enthusiastic and a valuable participant in the CTF. If you're submitting a write-up of a time played of a CTF played with Pwn Devils, then I will contact also the leadership, their leadership and so forth, to make sure that you were a presence the whole time. Otherwise, you can also play with people outside of the course. Absolutely, that's totally fine. Just list their names and in your write-up, and everyone should submit an individual write-up. Cool. All right. There's a second extra credit opportunity. No one took advantage of it last year because I guess we're just that good. Our first year, we went online. The framework went up, and within, I'm not making this up, I think like 35 minutes, someone had root on our server. It was horrible, and it was my screw up, of course. So that person emailed us. I had this bug bounty. That person emailed us and said, listen, there's this weird thing I found. What do you think? They got 50 points extra credit, 50 percentage points on their homework. So if you find a flaw in pwn.college itself, not in like the homeworks, tell us, to discourage obvious time wasting. I mean, honest mistakes happen, but if you start submitting every single security vulnerability in a challenge as a flaw to us and taking up a lot of time that way, we will start penalizing points. All right, final thing. If everyone is failing and then the course is just crashing and burning, if we overcorrected with the difficulty, we could deploy a curve. Don't expect this. I don't think we deployed a curve in previous years, right, Connor? Because the grading systems had an enormous amount of built-in extra credit. But this year, there's less extra credit. The only way, other than hacking pwn.college itself, to get extra credit is participating in CTFs once per weekend. All right. Relevant times for this course. Class hours are right now, obviously, Wednesdays 4:30 to 7:15. My office hours are Mondays 3 p.m. to 4 p.m. Arizona time on both Zoom and Twitch. Same as what's happening right now. Connor's office hours are Tuesday 2 p.m. to 3 p.m. Arizona time on Zoom and Twitch. Someone just asked on Zoom if PowerPoint is posted on the website. This one isn't yet, but I'll push it to the website, yes. And also, this whole Twitch stream is gonna... Oh, I forgot to click start recording, but whatever. We'll put the VOD from Twitch to YouTube. All right. Homeworks will be assigned during class. and homeworks are due at 4 p.m. There shouldn't be an approximately 4 p.m. right here. It is exactly 4 p.m. All right. Moving on. Someone asked, are the assignments on your own? Mostly, yes. So if you're trying something new this year, previous years, we have said, okay, you can do level 1 with your friends, but this is unworkable. We'll try to spend the last hour of every class for student collaboration. We'll split the Zoom into groups. I've never really used these breakout rooms functionality before, but we will try to use them. I encourage you to, in your breakout room, turn on video, share screen, go start typing away. And you can work together conceptually. You can exchange preliminary code. You can get a first step together on the homework. You should not exchange completed solutions because we will require write-ups with every flag solution. So don't get yourself into a corner where it's like, is this person cheating or not? Under no circumstances, during collaboration or any other time in this course, exchange flags. No matter what, if you exchange flags, we will go and get you for academic dishonesty. Don't do it. Make your own solutions. All right. Once the class ends, so at 7:15, when I end the Zoom, there is no further sanctioned collaboration. That's it. Yeah, that's all there is to it. So if you run into issues, you can still email us, post on Canvas. If you make a post, we can decide, okay, this question is fine, we'll make it public and so forth. Email or post on the Google group. There's a Google group that's linked off of the website. So Canvas is, of course, only for ASU students. Google group's accessible to the world. Please, don't spam the Google group with solutions. If you have to shut down the Google group, we will. It'll be a bummer. And come to office hours. Again, we have 2 office hours specifically created to be the day before the assignment due and 2 days before the assignment due, because from experience, that's when everyone comes to office hours. I'm going to stress very heavily, if you wait until Sunday night to start, you will fail this class. I mean, there's just, that's just the reality. Please start the homeworks immediately. Please. And as soon as you have questions, pose them. All right. I mentioned this is going to be a class about learning. All right. That's what cybersecurity is all about. Cybersecurity is an interesting subfield of computer science because it, in a way, depends on every other subfield. There are security problems everywhere. There's emerging security problems in machine learning. So I have to understand machine learning more than I ever thought I would as someone that doesn't do machine learning. There are security problems in algorithms, algorithmic attacks, and so forth. So I have to understand algorithms and runtime complexity and so on. There are security problems in human-computer interaction. Right? There's a recent paper that came out that showed that because of assumptions made during the Bluetooth pairing process, where you have to put in a pin and so forth, you can have a device that interjects itself between the device you're pairing and the device you're pairing it with. Because someone didn't think through the human-computer interaction, and the security researchers did. So you have to know everything in security. And this course encompasses an absurd amount of content. So please keep in mind that the course is about learning on the fly. By the way, one thing I forgot to mention, and it just totally slipped my mind when writing this slide, there is a makeup opportunity. So you can, at 4 p.m. on Wednesday, all the challenges are due, homeworks are due, done. Anytime after that, to the last day of classes, you can submit solutions for unsolved challenges for half credit. right? So you can still get half credit on challenges you don't finish. I would recommend you not to put that in all the way until the end. Use these built-in times, especially that final week of guest lecture when you have really gotten very good at security, to go back and earn the points, at least make up some of the points you missed. If that is not on the syllabus, I don't remember I wrote it there either. I will push it there shortly. But don't let it get in the way of voting. Make sure to vote if you can. All right. This class is going to be hard. It is going to be crazy, 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 crazy hard. Please make sure that you are equipped to approach this course. If you are not, please consider dropping the course. I don't want anyone to feel extraordinarily stressed for an entire semester. I want people to enjoy this course, right? But please make sure you're ready. A good way is look through all of those fundamentals. If there's anything that is completely unapproachable to you, it's going to be very, very, very tough. Connor, there's another harder than 471 question. All right. One caveat here, a complication. I say, consider whether you should be in this course or not. The drop deadline is tonight at midnight. That is an unfortunate thing. If this causes major issues for you and you're really, trying to figure out what to do, send me an email. We'll try to work something out, like figure something out. I just don't know what can be really done in the ASU, bureaucracy. It's just the way it was scheduled, and I will try to get it scheduled in a way where the first class is earlier. All right. Let's. One more thing. If you survive, then on certain small scales, you will be somewhat proficient as a hacker. It's a good launching off point. When I talk about the framework we built, pwn.college, to other people, I frame it as this: that pwn.college is a framework that takes white belts in security, so computer scientists that know computer science but don't know security, and it propels them to their yellow belt, so then they can start approaching those concepts. Someone raised their hand. Go ahead. Yeah, so there's this, the question, I'll repeat it, is what way is this course hard? Is it tedious? Are the concepts tricky? And the answer is both. There's a wide range of knowledge that we will be attempting to cover, a wide range. Their knowledge is also very tricky, right? In order to exploit a buffer overflow, which is one of the simplest things we'll do in this course, you need to understand how an enormous amount of things works in computer science. You need to have a knowledge of assembly, you need to have a knowledge of memory layout, a knowledge of the interaction with the kernel in regards to system calls, etc., right? This is definitely not easy. But on top of that, to make sure that you understand and learn this, there's a lot of practice problems, and they can be tricky in their own way, and they can take time to get through. So this will be a very, very hard class. Okay, someone on Zoom asked if they don't know assembly at all, should they drop? I would say yes. I'm sorry, but you need to know assembly. The fundamentals videos, someone asked on Zoom, where can they find them? You can find them at pwn.college in the first module link. All right. And then to answer other questions on Zoom, assembly was in 360. It should also have been 230. It should also have been in 365. All right. Let's. I have not read a computer science book in probably 20. Oh, so the question is, how different is this course and the difficulty of it to like a computer networking course based on a specific book? I haven't. Or, okay, this class will be very different from a computer networking class. We won't really talk about networking, actually. I mean, unless it shows up in one of the wildcard slots, we'll have very little discussion of networking, except for the mechanics of connecting into pwn.college and so forth. It's going to be really the internals of computing, the assembly language, what happens on that very low level that could cause a system to go haywire. Yeah. Cool. Okay, so that's all for this slide deck. Let's go back. All right, so Connor, we have how are we on the assignment? Okay, it's ready for use, because we could also use the archived old versions. Okay. Awesome. So, also to echo something that Connor said in chat, the Zoom chat, for the purpose of this class, you should be able to learn x86 given your MIPS experience. I'm not saying it's going to be impossible if you're missing any of the fundamental knowledge. It's just going to increase the difficulty of the class for every bit of fundamental knowledge that you use. Someone else said x86 is almost identical to MIPS. That's a terrifying statement to me. But all right. Anyways, let's move on. Yeah. I am not syncing up the concept with the 365. The question was right. So the question was, if someone's taking 365, are they going to be okay? I've seen people develop enough computer cybersecurity knowledge in 3 weeks to be top competitors on in the competitive circuit. So you could be okay. It depends on you. It's going to be harder and harder and harder the more you're missing. Someone's saying on Zoom, it sounds like no. I mean, look, I don't know. It depends on your background. Do you if you know Linux at a fairly good level, if you know some assembly, if you're proficient in C, maybe. If you're depending on 365 to teach you these things, this is going to be a very big shock here. I know it might come across that I'm trying to scare people. I just don't want to see people stressed and failing at the end, right? Please make sure you can approach this with enough of a background to make it viable. There was another. Yep. I think there'll be more concepts. Yeah, and some tweaks to a lot of them, but it's not significantly different. The main difference is, you know, we're virtual, and it's also open to the world. So what the other thing I want to say, if you're interested in this material and you're not sure and you want to keep going, you can always just crash the course, right, and then be in a very good position to hit it hard when you're ready. Someone is saying on Zoom that I'm trolling and the course is easy. The course might be easy for like Connor. Connor, do you think you could take this course right now? I can probably handle it. Yes, it's very easy if you have access to the back end of pwn.college. All right, so we have 18 minutes until collaborative time starts. Connor, do you want to demo pwn.college? Although how will we do that? That's impossible, right? All right, so Connor's going to tell me how to hack. It's going to be good. All right, so let's what is this for? What's the most useful topic here? This guy? All right. Okay. Cool. No, this thing went crazy. That's not even on anymore. Oh my god. Sorry, I have to fight with okay, and then the browser. Where is it? CTF time. Okay. All right. OBS has some quirks. All right. So I'm going to show off the platform. If you go to pwn.college, welcome to pwn.college. You can, again, get lectures off of YouTube. Boom. These are the fundamental series. There's a playlist of them all, including the intro. So you can just skip the intro. Please make sure that that is mostly review. Twitch is where we're streaming. Practice problems. Boom. We load up practice problems. This is the pwn.college practice problems. You can register, and we're going to have a leaderboard of ASU versus the world. I don't think Connor's been made aware of that yet, but it'll be developed shortly. And this is where everyone's going to go to do their homeworks, and we'll launch more and more homeworks here. If you want to, by the way, I don't necessarily recommend this, but if you're bored, want to take a quick look at past what we did in the past, here are all of the old modules from last spring, and you can also click through and go to our beta site from last spring. So anyways, you have to make an account here. Username, Zardis, email, pwn. All right, let's answer it. asu.edu. Password. Let's do that. Okay, submit. Boom. All right, so right now there's just one instance of Baby Suid. Connor will push more. Baby Suid is going to be the first assignment, and I will tell you what it is. Question here, does our username have to be our ASU ID? No, but your email has to be your ASU email if you're taking this course for credit. Also, I misspoke. Someone said that I said last spring. I meant last fall. There was some confusion on Zoom. All right. So, Baby Suid. Connor, is it hard to push extra? Because for the collaboration, it might be nice for them to have a good head start. Okay. Maybe push a couple more. All right. So anyways, Baby Suid is named after the set UID bit in Linux. I'm going to send out information about that and a lecture about Linux file systems and so forth after the drop deadline. I want to stress this is knowledge you should already have on how to use Linux. Tomorrow I'll post the lecture about this. All right, so click through. Here is someone already solved it. Oh, look, Connor solved it 2 hours ago. There are going to be 100 of these. Okay, each one will be worth 1 point. We click through and we say we enter a path to a binary that we're going to attack. This is unique for this challenge. I'm going to attack bin cat, and you'll see what this means. There is a run button, a practice button, a download button. Will this download bin cat, Connor? Okay, these two are broken for baby suit. We're trying, you know, it's in progress. It'll be, these will go away. So I click run challenge. It tells me, okay, you can connect up using SSH with a private key. And I can go to settings, SSH key, and set my SSH key here and connect to this to CSE 466.pwn.college with that SSH key, and it'll drop me into a terminal with my challenge running. If that doesn't make sense to you, please go and check up on how SSH works. All right. So go to challenges, click here. I already hit run. It's ready. If I don't want to connect over SSH, and more specifically here, I don't want to deal with, you know, getting OBS and my terminal. Oh, I have it run. Anyways, the other thing you can do is click terminal, and it just drops you into the terminal right away. This is nice and easy, no messing with everything. You are actually behind the scenes connected in to our infrastructure running this challenge. All right, so here is this challenge. I am user CTF, and I need to leak the flag. Connor, flag is world readable. Yeah. Oh, really? Here. Yeah, so that should be fixed ideally. So, anyways, normally this flag won't be readable, world readable. It's going to be it won't have these permissions. It'll just have these permissions. So if I do cat flag, it'll something very similar will happen as if I cat Etsy shadow. Connor, Etsy shadow is also world readable. Oh, lol. You're right. Okay. The flag is world readable. All right. We are having trouble zooming in this terminal. Okay. All right. God damn it. Did my browser go nuts again? Hold on. I'm going to real quick. What's going on here? Okay, here we go again. I'm going to actually connect over SSH because then I can zoom in easier. So SSH requires an SSH key. Let's switch to my terminal to SSH keygen and give an output of pwn.college -f. Okay, so I have an SSH key pwn.college.pub. This is my public key for SSH. I take this and I put it here. I hit update. Public key has been updated. I go back to my terminal, and now I can do SSH-I pwn.college. That's the private key. CSE 466.pwn.college. If you're, you want to make sure everything works, you hit -V. And hold on, what is CTF at, right? Oh, CSE 466 at. Okay, cool. I connect. It works, and I am in this baby suid, but you can now read my terminal, unlike in the terminal. So 2 ways to connect. One is the terminal, one is that. All right, I want to show you what happens when you specify bin cat as 2 people have raised their hands. So 1 person go. Yeah, so type in bin cat, then get in there and look around at other programs that are valid. Connor, you filter by ELFs and everything? Oh, okay. We should send out a list of valid targets. Yeah. Cool. Okay. Someone is saying the terminal is showing up as a plain gray screen. That likely means there's a connection error. Oh, you haven't started the challenge. Okay. Anyways, so if you want to get an idea of the Connor, we pushed the Docker image, right? No. Yeah. Okay, we're gonna push a Docker image so you can pull the container. It's 30 gigs if you want to pull it. All right, let's go and restart this challenge. Connor said he updated so the flag's no longer readable. Okay, I've restarted the challenge. I'm gonna SSH back in. No, what happened? Connection, no search container, user 43. I hit, I had the same problem. Can you pre-fill bin cat here, just by default? Okay, awesome. Okay, I'm in. Now you can see flag is only readable by root. So say if I use the more utility to read out the flag, I get permission denied. However, I can see that cat, because I entered it when I was launching the challenge, is set UID, has set UID permissions. This means that when it executes, regardless of the user that's executing, it'll run as root. This should be review to you. That means that if I use cat, bin cat, to cat out the flag, it'll work. So this is my flag. Do not submit this flag. Get your own cat flag. Super easy. You use bin cat and you put in the flag. Okay? Or you put in the /flag and you will get the flag. Cool. Now we can, are there any questions? There was a second person raising hands. There's a question on Zoom. How do we know what challenges need to be done? We'll post a list of valid targets. It's a quick list. You can use any binary that is an ELF file. Boom. All of these that are scrolling by are valid targets. And of course, this will all be archived on YouTube. There's a lot of targets here. You should not have any trouble finding valid targets. So as you can see, it's still scrolling. Let's see. How many of these were there? Quite a lot. $9,415 at least, and there might be more in other paths, and you need to find 100. Cool? Okay. So, what is left to talk about? Cat flag. Oh yeah, here's the command to find valid targets. What happens when you launch the service? It'll make the path that you specified set UID so that you can use it to read the flag, and you have to figure out how to read the flag. It's very easy with cat. Cat is a Linux program. This should all be reviewed. Again, Cat is a Linux program that reads out a file. More is another one like that. So you can also, that's another free point for you. But can you get the flag with dmessage, a Linux program that prints out your kernel log if it's permitted? I can. So you should be able to as well. Cool. So yeah, this is the first homework. Please make sure, I see already some confusion on Zoom. Please make sure you're on csc466.pwn.college, not over here in the old Baby Suid archived module. I'll put a bunch more warnings here. If you go to gtf.pwn.college, this is the old beta version. These will not be scored, okay? But you can, also just don't get confused. csc466.pwn.college. All right. Someone is asking, how do we solve instance 1 100 times? We're going to upload instance 2 through 100 very shortly. Instance 1 is just the thing you can do for now. All right. Awesome. Every instance will require you, of course, to put in a different path over here. Cool. Is the score auto-record if you get the flag? So what happens if you get the flag? You go here, you paste it in here, you hit submit. Actually, let me show you. So we launched it with bincat. Oops, I was already running it. Kick me out. Success. We cat the flag. We get the flag. I get the flag, and I submit it, and I have the flag, and it's auto-scored, and it turns green. Boom. It also tracks what you've already solved. Nice and simple. I go to scoreboard, and I see that I'm tied with a bunch of people for one solve, and that one solve is, oh, it no longer shows. That's cool. Connor, it no longer shows the path. That's great. Cool. All right. I think this is, by the way, you don't have to have your SU right on your profile, just your SU email address. The email address is private. Your profile, make a cool hacker handle. Try to get as cool as Kanak or Zardus, right? There's a guy, hacker handle Fish. I mean, what the hell? That's amazing, right? Hello_world is not bad. Okay, cool. So, that is it. We are now going to start, actually right on time, shockingly. I'm going to split everyone into, yeah, you can change your handle in settings. Someone asked on Zoom. Go to settings, change your username. Super simple. Coolio. Okay. Any final questions before I start the group, the collaboration assignment? Also, by the way, you can register as many accounts as you want if you want to try out several different try out instance 1 several different times. Oh, great! You can try other ones. So just keep those flags for later when you push instance 2 and so forth. You can submit it. Oh, those flags don't work. You can redo the solution. Keep track of the solution. Okay. Yes, whoever just said they entered their generated SSH key, almost certainly you entered your private key. Upload your public key. Will this lecture be recorded? Yes, provided the Twitch and YouTube integration works properly. Is there a submission API for flag submission? That's a Connor question. Or post it on Canvas or send it to the Google group. We'll take a look. Probably yes. I mean, it's a customized CTFD. Yeah, Connor says yes. Okay, very cool. I think this is now the beginning of the collaborative portion. I'm going to assign everyone into breakout groups. Oh, wow. During the course of this lecture, Connor, we lost almost a quarter of the class. That is, usually this class has about a 60 to 70% drop rate. that is normal. But please, a lot of people end up staying in and needing to withdraw afterwards. So please make sure that you are ready. Okay, breakout rooms. Automatically assign. I'm gonna assign breakout rooms so that there are kind of, what do you think, 4 people per breakout room, or should we do 8? CTF team. Okay, 7 to 8 per team. I'm going to click this. Some team is going to get screwed because I will jump in and then I will jump out right away. Some team will get screwed because Connor will do the same, but that's just how it is. I'll up it so that it's 8 to 9, so that, you know, hopefully it's still good. Okay, everyone get ready. Warm up pwn.college. Remember, you don't need to do SSH, but it'll be easier and so forth. Otherwise, once I click this, I will stop the stream, start the process of uploading this to YouTube and everything. Thank you for tuning in. I'm going to post more kind of in the fundamentals series tonight or tomorrow, talking about Linux file system permissions and so forth, which is this first module all about. And then we'll see you next week when we'll go into shellcoding. Awesome stuff. All right, I'm about to click create room. Everyone will go away. Those on Twitch, goodbye, Twitchers, and see you next week.